All right, picking up where we left off, we need to find f prime of 3. Well, sounds easy. Let's go to our table. So I'm going to fold this just a second so we can see everything at once. So f prime of 3, oh no, there's no 3's. So if I want to find f prime of 3, I am going to have to use the slope between the point at 4 and the point at 2. So f of 4 is 5. F of 2 is 3. All over 4 minus 2, we get 2 over 2, which is equal to 1. Which means to get f double prime of 3, we need to use the slope between 2 and 4 using f prime, because the slope gets the derivative. So if we use f prime, the slope will give us f double prime, just like we used f and it gave us f prime. So f double prime of 3 is equal to f prime of 4 minus f prime of 2 all over 4 minus 2. So we get 3 minus 1 all over 4 minus 2, which is equal to 2 over 2, also 1. All right, number 9. Ooh, a little bit of integral action here going on. So I am going to evaluate this, but if you notice, it's a function plugged into a function, so I'm going to need a u. I'm going to make my u 2x, which means du dx equals 2, or du equals, du over 2 will equal dx. So let's substitute that in. G prime of u du over 2, and let's change our endpoints. So my endpoints started as 0 and 2. If I plug a 0 into 2x, I get a 0. But if I plug a 2 into 2x, I get a 4. So now I can anti-derive. I need 1/2 from the 2 here. I'm going to pull that out front. G of u from 0 to 4. So I need 1/2 g of 4 minus 1/2 g of 0, which gives me 1/2 g of 4 is 5, minus 1/2 g of 0, which is -2, for a grand total of 3.5. Again, this answer would be acceptable. I'm going to the final answer because it's easier for you to check your work with me if our final answers match. Now, h of -5 is a little bit tricky because they give us h prime. How in calculus do we go from an h prime to an h is an integral? So I know it's going to involve an integral, and I know I'm going to want to end at -5 because I want h prime of 5, but I need a starting point. So if you look at all of our information, we have to find a point that we already know on h. And that's where this h of 2 equals 5 comes into play and is rather useful. I'm going to slide up here. I think we're only going to need h today. But we're on this problem. So if my point is 2, 5, then I'm going to start at 2, and I have to add the value out front. This is kind of like I was 5 feet tall. Now let's see how much I grew between 2 and -5. Now to do this, -5 is smaller than 2, so I need to switch them, which means putting a negative out front. And now I'm trying to find the area under h prime of x from -5 to 2. So we're talking about this triangle and this half a circle. So if I write that, my triangle is 1/2 base times height. Oh, said 1/2, wrote 1/3. Plus my, and actually this is negative area, so make sure you consider it negative area, plus this positive area, which is half of a circle of radius 2. So I end up with 5 plus, these will cancel out, 3 minus 2 pi, or 8 minus 2 pi. And either of these answers at the bottom would be acceptable. You are not required to simplify, but Can if you want. Again, always take time into consideration. All right, so h prime of 6 is going to be very, very, very similar to what we just did in number 10. We need h prime of 6, which means we need a 6 in our integral, and we still have to start at 2 because that's the point we know. Could we start at this -5 value that we just found? Sure, but if you messed up here, then this ends up being wrong. So it's always safer to go back and use the point that we know for sure, which would be that provided 2, 5. So these are in the right area, so I need the area from 2 to 6, which is a negative area because it's below the graph. It's -1/2 4 times 2, base times height. So we end up with the 5. Those cancel, -4 equal to 1. All right. Now, h prime of -3, h double prime of -3 means we need the derivative of h prime at -3. Well, if you look at this, -3 has a point. Can we derive at a point? No, so this equals no solution. You may want to write can't derive at a corner, or not differentiable at a corner. All right, so moving on to number 13. Number 13 says find L prime of 1. So I need to find L prime of x first. And notice it's a product. So we're going to have to do the product rule. So we get sine of pi x times g prime of x plus g of x. Now be careful when you derive sine. Sine's derivative is cosine. But then we have to multiply by the derivative of the inside, which is pi. So for L prime of 1, I'm going to need sine of pi times g prime of 1 plus g of 1 times cosine of pi times pi. So sine of pi is 0. G prime of 1 is 4. Doesn't really matter because we're multiplying by 0. G of 1 is 1. Cosine of pi is -1 and pi. So this term is gone. We get negative pi as our answer. 14, similar idea. We've got two products that are multiplied, so we are going to have to use the product rule to find m prime of x. First, times the derivative of the second, which is going to need the chain rule. Derive the outside, the g, without changing the inside, then multiply by the inside's derivative, plus g of x over 2. Derivative of e to the 2x minus 4 is e to the 2x minus 4 times the derivative of 2x minus 4, which is 2. So now let's simplify a little while we plug this number in. If I plug a 2 in here, I get e to the 0, 2 times 2 minus 4, g prime of 1 times 1/2, plus g of 1 times e to the 0 times 2. So e to the 0, anything to the 0 power is 1. G prime of 1 is 4 times 1/2. G of 1 is 1. E to the 0 is 1 times 2. This becomes 2 plus 2 for a grand total of 4. Almost done here. 2 more problems. 15 wanted me to find g double prime of 1. Well, to do that, it's very similar to problems 7 and 8. We don't have g double prime, but we do have g prime. So if I want to find g double prime, I take g prime values and do the slope. Well, here's 1. So I'm going to use the point on either side. So g prime of 3 minus g prime of, we're doing 1. So g prime of 2 minus g prime of 0 all over 2 minus 0 equals g prime of 2 is 3, g prime of 0 is 2, and we get 1/2. Let me double check that. G prime of 2 is 3, g prime of 1 is 2. Yep, good. And finally, we need to find n prime of 0. First, we need n prime. If you notice, this is a chain, needs the chain rule because f of x is plugged into g of x. So g prime of f of x times the derivative of the inside, f prime of x. So we need g prime of f of 0 times f prime of 0. So we've got g prime. F of 0 is 1. And then f prime of 0 is 5. G prime of 0 is 2, so we've got 2 times 5, or oh, I lied. G prime of 1 is 4. Or why I wasn't getting the right answer. G prime of 1 is 4. 4 times 5 is 20. All right. Thank you very much. I will post another one of these. This will go up. Yeah, I'll post another one of these once we do the next chunk, 16 through 28, I believe. So check them out. Thanks.